Hello, good morning, everyone. This is Nitin Jha, and I'm presenting my work on utilizing machine learning techniques for quantum augmented networks. And we have proposed a quantum augmented HTTP protocol. So, the main idea behind this work is that developing an entire quantum network in the future or quantum internet in the future is very impractical as of now because there are a lot of technological limitations such as the attenuation loss in quantum channels lead to qubit disappearing over longer distances, thus rendering the quantum network useless uh, for very large area. So we need to come up with some solutions, and for that, we come up with quantum augmented networks, which basically means utilizing the strengths of both classical networks and quantum networks to develop an quantum enabled or quantum augmented classical network. So that means we'll take the classical network stack and we will put quantum components on it to increase the overall security, while the classical components can be used to increase the overall efficiency of the model. So here we start with proposing a modified HTTP protocol. We chose HTTP protocol because it's one of the most highly researched protocol and it's quite simple in nature. So how we propose to do it is now instead of just having the headers, the classical headers, it will have both classical and quantum headers. The quantum headers will let the device know what kind of quantum protocols was used while encryption and will help in decoding it as well. So the figure 2 in the poster shows a modified network. So how it would work is we have proposed a NLP model. So here we have used LSTM, BiLSTM, and some other models to classify incoming textual message. So it can be an email, a text message, or anything textual format. So that NLP model has the capability of classifying that particular message into private and non-private sections. So it can take the message and be like, okay, this message would be private in nature, so it would need quantum encryption. So the idea here is that not all messages require quantum encryption because they don't require that level of security. So what we'll do is we'll have to classify when the message has some extremely private content. Let's say you can have your SSN in there, or if it's a government communication, then there might be some key, some security key or something that's very important. So we would classify all those as private information and then just encrypt those as quantum encrypt using quantum encryption. So we can use several quantum protocols like three-stage protocol uh, and many more quantum secure direct communication protocols. So yeah, the testing parameters would be the normal BERT metrics like F1, recall, and all that as of now. And then we would put this NLP model stack into a simulation, a network simulation, where when a user enters a message, it will allow the user to choose or will prompt them that, oh, this is a classical message or this is a quantum message. So this work was actually previously presented at IEEE Quantum Week earlier in September of this year in Montreal. And yeah, if you have any more questions, do reach out to me. Thank you.